So John, tell us something about Columbia and...
Yeah, absolutely. So I'm John Kymissis, and so I'm a faculty member in electrical engineering at Columbia University. Columbia is located in New York City, and it's a pretty big university. So it has all the disciplines, but we have an engineering school which is about 300 faculty, and within that, about a tenth of the faculty are in electrical engineering, and I'm there, and I work on thin film electronics. I work very closely with folks in other departments in chemistry, material science, and mechanical engineering, which at Columbia also has a lot of solid state physics, and applied physics, which also has material science at our university. People often ask me, like, are you a scientist? I'm not a scientist, I'm definitely an engineer. But what is an engineer? An engineer is a scientist who's trying to solve a problem. And some of the problems are, I'll call them kind of market problems, but like one of the things that we worked on, if you remember, in the synchrotron was trying to substitute copper for gold. That was one of the big things that we did. And gold is a conflict mineral, it's expensive, but it has excellent performance, and understanding why gold gives good performance and ways to substitute copper, and what we were able to show in, I think, one of our better papers is that we can do some surface treatments on the copper which give a performance better than gold. Yeah, and I think it's questions like that are really important. Having the powerful tools like you have in your institute, I think, are really useful for that.
It's important to have photovoltaics to produce energy, but also to have electronics displays, to have low power electronics.
Absolutely. Displays are an area I'm really interested in. And I just 2 weeks ago was at the Society for Information Display annual meeting, which is a very exciting event. And like you said, it's we use them everywhere, but pushing more electronics into the displays has been a really interesting area because, like you said, you can push a lot of sensors in, but also the same technologies that are used for displays are also used for other things. So for example, X-ray sensors. When you go to the doctor, they want to take an electronic X-ray. How do you make an X-ray panel display? It's actually the same technology that's used to make a display, just working backwards. Of course, it's much more complicated because, in a display, you don't have to worry about noise, and the voltages are different, and the integration is different. But, the companies that focus on that are, using similar technologies to do other things. And like you said, your phone now, fingerprint sensor built into the phone, much higher luminance, and new types of displays. It used to be 20 years ago, 30 years ago, when I was a student, there were only two types of displays. You had CRTs and you had liquid crystal displays. Today we have electronic paper. You have displays that work, like you said, in the car, in the screen, in the window, displays that warn pedestrians on the front of the car. All of this is like new electronics, different electronics, and in order to make them, you have to understand what's going on, as I like to say, under the hood. Because every time you have a new material system, a new process, even just the cleaning of each of the semiconductors, we have to understand the surface science and exactly what's happening.
Yeah, and the point is that, Vitality here in Perugia has a spoke involving nanomaterials, and all the new materials, you must know everything, every single property, electronic, chemistry, physical, whatever, down to the nanoscale, or no new materials.
Yeah, absolutely. My first job was at a company called QD Vision, which long after I left was acquired by Samsung. And so if you've seen, QLED TVs, that company, I was there. And there, that was a lot of fun for me because it was a perfect mix of chemistry, surface physics, electronics, everything put together. Because, that too. It was, the idea was there was a lab where they synthesized quantum dots. So, I helped build the furnace for the quantum dots and the Schlenk lines and all that. I'm not a good chemist. We had a whole purification lab, which was like an explosion waiting to happen, of course, distilling all the solvents. But then I was really in the clean room side. And so we had a little window, the quantum dots would come in a little bottle in the window, and then we would take them, and we had printing, the cleaning, the transport layers, the semiconductors. There's a lot of everything together. And what's amazing is, even in the first few months of the company, we had devices that worked, but it was only because we had all of the disciplines at the same time pushing in the same direction.
Yeah, you mentioned that you were in a company that you made.
Oh, I can't take credit for making. I was the first employee.
Okay. No, but I'll tell you this because the Spoke 9 has the idea to create, I would like to call it a technological pole, but it's not technological. I mean, it's the traction pole. Mm-hmm. Not far from here, it's in city in Valdottadino. Mm-hmm. Now they are fixing and finishing the building, and there will be built an entire laboratory with top equipment, and this will be given to companies who come there with their research and development, but also for measurements. So the idea is to give a big expertise of people, so know-how, plus equipment, which usually has a bigger cost for, I don't want to say small, but even for medium or big companies.
Yeah, absolutely.
And probably the most valuable thing is the knowledge.
The people who know how to use it, exactly.
Yeah.
Like, you can get a TEM for free, but you need somebody who really knows what they're doing to run it. And that is, absolutely. No, and that's huge. I mean, one thing we'll talk about tomorrow is, having that ecosystem. A company, how much money do you need to start a company? In the end, it's maybe, let's say, 2 salaries. But just the 2 salaries, if you're in an office by yourself, what are you going to do? Maybe you can make an app or something. You can do some programming. If you want to make something, like you said, you need some equipment. But small company, just one microscope is real money. And the truth is, at the university or at an incubator, there's equipment that's used maybe 10 hours a week. What is it doing the other 90 hours a week that it could be used. So finding ways to build that ecosystem where people can use the facilities, take advantage of expertise that's already there, collaborate, is really valuable, because then you don't have to raise all of the cost just to have it work only 1 hour a week for the small company. Small company, okay, it should own the things that are essential for it. But a lot of times, like you said, characterization equipment, clean rooms, facilities, you don't need to own all of that to be able to use it when you need it, which is not all the time.
So, John, thank you so much for being here. We have a couple of ideas now.
Yeah.
And I hope that these ideas can become a real project.
I think thanks for inviting me in the Vitality Project. Yeah, I look forward to expanding all the things we're doing.
Okay, perfect.